Hi everyone, we're on our day 5 notes. This is proving trig identities. We are going to start by just writing down some basic trig identities that are important to remember. So let's recall that secant of theta is equal to 1 over cosine theta. We have cosecant of theta is equal to 1 over sine theta. We have cotangent of theta is equal to 1 over tangent theta. Okay, and then let's also recall that tangent of theta is equal to sine theta over cosine theta. And that's our y over our x. So then our cotangent of theta, we can also just say is cosine theta over sine theta, which would be x over y. Okay, then we get into a little bit more complex. So it's important to know that sine squared theta plus cosine squared theta equals 1. So sine squared theta plus cosine squared theta equals 1. Now that can be manipulated a few different ways. We can also say then that sine squared theta is equal to 1 minus cosine squared theta, or cosine squared theta is equal to 1 minus sine squared theta. So these two go together based on this top one. And then last, let's just make a little note that if we have sine of theta squared, that does not equal sine theta, the whole quantity squared. Those are not the same, so make sure that you do not use those as being the same. All right, so to prove a trig identity, we are going to be following some of these rules. We are going to always work with one side of the equation that is always or most likely going to be the more complicated looking side. Next, we are going to substitute as much as we can with using sines and cosines. Then we will factor and we'll cancel common factors. Then we can add or subtract fractions using common denominators. We're going to rationalize the denominator by multiplying by the conjugate. And then we will multiply by 1 or anything that is equivalent to 1. So we will be doing that most of those steps in this first problem. So we are going to be using some of our textbook examples. So our first example is going to be number 46 from the textbook. So we have tan squared of a plus 1 equals secant squared of a. So it looks like the left-hand side is a little more complex, so that is the side that we will work with. So the first thing I'm going to do is instead of writing tangent squared, I want to change that to cosines and sines. So I am going to change that to be sine squared a over cosine squared a. Now I'm adding 1, but I can recognize that my denominator is cosine squared. So that's what I'm going to change 1 to be by just multiplying by cosine squared a over cosine squared a. Okay, and that is equal to secant squared a. So my goal here is to get the left-hand side equal to the right-hand side. Okay, so now I can say that I have sine squared a plus cosine squared a all over the common denominator of cosine squared a. And that equals secant squared a. Okay, now using those trig identities up above, sine squared a plus cosine squared a equals 1. So I have 1 over cosine squared a is equal to secant squared a. And 1 over cosine is equal to secant. So in fact, I do have secant squared a equal to secant squared a. So my right-hand side equals my left-hand side, and I am done. I was able to prove that trig identity. Moving on to number 50, we have 1 over sine theta minus sine theta equals cosine or cotangent theta cosine theta. So let's go ahead and rewrite this. I know that sine theta is over 1. I want to have a common denominator, so I'm going to go ahead and multiply the top and bottom of sine theta over 1 by sine theta. Okay, so I have 1 over sine theta minus sine squared theta over sine theta equals cotangent theta cosine theta. Okay, and I am again going to be working with the left-hand side since that does appear to be more complicated. A good hint to look for is if there's any addition or subtraction, that's the side you're going to want to be working with. Okay, so now I can go ahead and subtract. So I've got 1 minus sine squared theta over sine theta is equal to cotangent theta cosine theta. I know that 1 minus sine squared theta is also equal to cosine squared theta, and that was one of our trig identities that we wrote up above. Okay, now I'm going to write this out as cosine theta times cosine theta. So we've got cosine theta times cosine theta over sine theta. Okay, now if I look at cosine theta over sine theta, hopefully we can recognize that that is the same as cotangent. So I have cotangent theta times cosine theta is equal to cotangent theta cosine theta. So I was able to get my left-hand side equal to my right-hand side. Okay, number 51, we have cosine of A times the quantity secant A minus cosine A is equal to sine squared A. So let's rewrite this only using sine and cosine. And once again, the left-hand side is more complex, so let's use that side. So I am going to have cosine of A times 1 over cosine A minus cosine A is equal to sine squared A. Now I can go ahead and distribute. So cosine A over cosine A, that's just going to give us 1, but I'll write it out first. So cosine A over cosine A, and then minus cosine squared of A is equal to sine squared A. Okay, so then cosine A over cosine A just is going to simplify to 1. So we've got 1 minus cosine squared of A is equal to sine squared of A. And if you remember from our trig identities that we wrote in the box up on the first page, 1 minus cosine squared of A does equal sine squared of A. So sine squared of A is equal to sine squared of A. Number 54, we've got cosine of theta minus sine of theta squared plus 2 sine of theta cosine theta equals 1. So very clearly, the left-hand side is more complex. So the first thing I need to do is double distribute. So I am going to have cosine theta minus sine theta times cosine theta minus sine theta. Okay, so if we double distribute, I have cosine squared of theta minus 2 sine theta cosine theta plus sine squared theta. Now I can add in my plus 2 sine theta cosine theta, and all of that equals 1. Okay, well now I can go ahead and cancel out my 2 sine theta cosine theta with the negative 2 sine theta cosine theta. So I am left with cosine squared theta plus sine squared theta equals 1. And again, cosine squared theta plus sine squared theta, that was one of those identities that we wrote on the front. 1 equals 1. So I was able to prove this identity. Okay, number 57. These problems are going to start getting a little bit more complex now. So remember that you can always pause the video to work a little bit slower and write out more steps, and then you can always unpause to double check. Okay, so we have sine of A plus cosine of A equals sine of A over 1 minus cotangent of A minus cosine of A over tangent of A minus 1. So this time the right-hand side is more complicated. So our first step is going to be to rewrite this with sine and cosine. So I am going to have sine A plus cosine A is equal to, I've got sine of A over 1 minus cotangent, remember, is just cosine A over sine of A minus cosine A over tangent is sine of A over cosine A minus 1. Okay, so I want to find common denominators. So if I am looking at this first fraction, I am going to want to multiply the top and the bottom by sine of A. Okay, so let's write that out. So I'm going to multiply this entire quantity by sine A over sine of A. So if we do that, I've still got my sine A plus cosine A, and that's going to be equal to sine squared A over, distribute that sine of A, so I've got sine A minus cosine A sine A over sine A. Okay, now let's look at the second fraction. Now that one I'm going to want to multiply the top and the bottom by cosine A. Okay, so I've got minus cosine squared A all over sine A cosine A over cosine A minus cosine A. Okay, looks pretty complicated, but we can cancel a few things out. So what I want to cancel is going to be my sine of A here, and then my cosine A there. So if you notice, both of our denominators are going to be sine A minus cosine A. So sine A plus cosine A is equal sine squared A over sine A minus cosine A minus cosine squared A over sine A minus cosine of A. Okay, now that I have common denominators, let's go ahead and subtract. So I've got sine squared A minus cosine squared A all over sine of A minus cosine of A. Okay, now let's go ahead and look at my numerator here. We should remember, or this should look kind of familiar back to, our algebra classes. If we've got y squared minus x squared, that's just going to be x plus y times x minus y. So let's go ahead and factor this to be in that form. So my left-hand side stays the same. Now let's rewrite this as being sine A plus cosine A times sine A minus cosine A. I still have my denominator of sine A minus cosine A. Okay, now hopefully we can see the purpose of that was to cancel out sine A minus cosine A, and what I am left with is actually the left-hand side. So we've got sine of A plus cosine of A is equal to sine of A plus cosine of A. All right. Number 75. We have secant of theta minus cosecant of theta over secant theta plus cosecant of theta equals tangent theta minus 1 and tangent theta plus 1. So this time, they're both pretty complicated, but it looks like the left-hand side might be a little bit more. So let's rewrite that to be all in sine and cosine. Okay, so secant is the same thing as 1 over cosine. Cosecant is 1 over sine. And then the right-hand side I don't change. And I know that's not sine or cosine, but that's what we're trying to prove, so we are going to leave it. Okay. Now I want to multiply both the top and the bottom by sine theta cosine theta because that's going to give me a common denominator. So I'm going to use a different color, multiply the top and bottom by sine theta cosine theta. So I am going to end up having sine theta cosine theta minus sine theta cosine theta all over cosine theta over sine theta over, try it again, sine theta cosine theta over cosine theta plus sine theta cosine theta over sine theta, and that entire thing is supposed to equal tangent of theta minus 1 over tangent of theta plus 1. Okay, now let's go ahead and cancel a few things out. And let's simplify that. So I am left with sine theta minus cosine theta all over sine theta plus cosine theta. And that is equal to tangent of theta minus 1 over tangent of theta plus 1. Okay, so we're still not done. I'm getting close, but I need to somehow get that minus 1 and plus 1. So let's divide both sides by cosine. So if I divide both sides by cosine, I guess it would be the other way. Let's divide both sides by cosine. That will give us sine theta over cosine theta, okay, because I'm going to be distributing. Okay, cosine theta over cosine theta is going to give me 1. Then again in the denominator, sine theta divided by cosine theta. If I distribute, that's going to give me plus 1. We're getting closer. That equals tangent theta minus 1, tangent theta plus 1, and then sine of theta over cosine theta equals tangent theta. So rewrite it. We've got tangent of theta minus 1 over tangent of theta plus 1 equals the right-hand side. And we're done.